Hello, calculus. This is 9-2, and it's partial derivatives. I'm hoping you saw that coming since we started with the difference function before, because this is exactly what it led to last time, and it leads to it again. So you should have 9-2 notes out. You will need a calculator, and let's go. All right, we're going to calculate partial derivatives. We're going to evaluate it. We're going to do some application, and then we're going to do a second order partial derivative. I think you'll enjoy all of this, actually. They're quite fun. All right, so when you do a partial derivative, it has to tell you in which variable you are deriving. So a partial derivative with respect to x means you are only looking at the x variable. With respect to y means only the y variable. You also have to remember if it doesn't have an x or a y in it, so if this is x and I have a 2y, that there's considered a constant and goes away because there is no x value. So don't forget that, even though there's a variable if it's not the right variable. Okay, partial derivatives. So we're doing the derivative of f is what this means with respect to x. It's a partial derivative because it's not x and y. This is where we started before we did our limit functions. The same is true with y, and that is what we did last section. All right, so when you're doing these derivatives, you have to know what you're doing it with, and this is the notation I use, it's f sub x. The f sub x means I want to do the derivative with respect to x. So when you look at this function here, the x is the variable, and the 2 and the y cubed are considered the constants. And the same over here, the 6 and the y4 are considered the constants. Because that's true, I'm just going to regroup it so it's easier for you to see. So we put the 2y cubed together because I'm deriving with respect to x, and the 6y to the fourth together because I'm deriving with respect to x. So now you do your derivative. So that's 2x times this. This in here is 5x to the fourth times the coefficient in front. Then you just do your math. 2 times 2 is your 4, xy cubed, put it in descending order. 6 times 5 is your 30, x to the fourth, y to the fourth. Again, descending order. Now, if I ask you to evaluate f of x at -1, 2, you just plug -1 in for x, 2 in for y, like we've done here. Type that in your calculator and you get your answer. All right, now let's see what it looks like with respect to y. So now I grouped the x with the coefficient because it's now considered a number. It's not what we're deriving. The same here. So we do the derivative of y, which is 3y squared, and the derivative of y to the fourth, which is 4y cubed. Do your math. So you got 6 x squared y. Here you have 24 x to the fifth y cubed. I did not ask you to evaluate, so that one's done. All right, pause and try yours. I want you to find f of x and f of y. So first step, you should have done f of x of xy. This one here would have been 8x, 9xy. You're deriving only the x. Remember, this is like -9y times x. Well, that's just 1, so that's -9y. And this has no x, so it's considered a constant, so it doesn't have a part of my derivative. This is finished. I hope you did well with that. Okay, now let's try the f of y. See how you did here. So this time the y is important. So let's regroup this. We've got the 4x minus the 9x times the y plus the 6y cubed. Again, here there's no y, so it's considered a constant. It goes away. This with respect to y, just minus 9x. This one here is plus 18y squared. And that is done. Now I asked you to evaluate f of y, so that's this one, at 2, 1. So we plug in the 2 for x and the 1 for y. When you did that, your answer should have been 0. I hope you did well. Be careful with your negatives when you're doing those. Okay, I'll show you some application. I got 0.1 xy squared, natural log of x2, 2x, 3y, and 2. X is the size of the labor force. Y is the amount of capital invested. So this is how many people do I have? This is how much I'm investing. I want to find the marginal. again, that word marginal, productivity, which means I have to find the first derivative, and capital. Okay, labor we're going to do together. Capital, you're going to do the exploration of. At when x equals 50 and y equals 20. So I'm going to do labor with you. So that's p of x. So when we do p of x, I rewrote 0.1 y squared is the coefficient. The derivative of x is 1 times the natural log, right? So you're doing the product rule here. So I took the derivative of the first times the second plus the derivative of the second. Now remember, the derivative of the natural log is 1 over the original times the derivative of the inside. Well, we're doing x, so we're only going to look at the 2x here. And that's where this 2 came from, times the original first one. Okay, now we're going to plug in 50 and 20. Type that in your calculator, and you get 228. All right, so that's marginal productivity. Now it's your turn to do capital. So your capital, you're doing, P of y, because that's the capital. Now look how it's grouped. So the first one, we're going to take the derivative with respect to y. So that's 0.2xy, because the y doesn't go away because it was squared, times the natural log, so we're still doing the product rule. 2x plus 3y plus 2. Okay, now we're adding the derivative of the seconds, the derivative of the natural log, which is 1 over 2x plus 3y plus 2, all times the derivative of the 3y, which is just 3. I'm going to put it in the numerator so it's easier to see. Okay, we've got our derivative done of the first one. Oh, I forgot to multiply it by my original. I am so sorry. 0.1xy squared. There we go. Now that looks better. So we have the derivative of the first times the second plus the derivative of the second times the first. We have all of our numbers. I want to find the margin of productivity of capital. Oops. It's supposed to be the number of 50 and 20. So now let's plug our 50 and 20 in. So we have 0.2 times 50 times 20 times the natural log of 2 times 50 plus 3 times 20 plus 2 plus 3 over 2 times 50 plus 3 times 20 plus 2. Oh, I am so out of room. This is all times, sorry about that. My decimal disappeared too. 0.1 times 50 times 20 squared. You type that all in, you should get 1055. Nicely done. Okay, second order partial derivatives means you take the derivative you found and you do it again with another variable or the same variable. So right here, I want to do the derivative with respect to x. Then I want to take the derivative, okay, I want to take the derivative of z with respect to x. I want to take that derivative with respect to x again. So I'm doing a double derivative with respect to x is what this means. Here again, it's the double derivative. This time I want to do it y and x. Here, double derivative with respect to y only, so y squared. Double derivative with respect of x, then y. This is how I usually write it with the subscripts. Both of these are completely okay though. If you like the other one better, please use it. All right, I want to find f of x. So we look at this and we do it with respect to x. So I got negative 12x squared, negative 6xy cubed. There is no x here, so it disappears. Now to find f of xx, I take this one and I do x again. So I take this one here, which gives me negative 24x. This one is a negative 6y cubed. Done. Now, try yours. You're going to find f of y, same function. So your first one, your f of y, is going to equal, the first one's going to go away because there is no y. You're going to do negative 9x squared y squared plus 4y. Now the second derivative, so f of y. Do it again with respect to x, so that's negative 18, y, x squared y plus 4, and that's done. That's your double derivative with respect to y. Now, same function, but we're going to do x then y. So you're taking this one here that you just did, f of x, which is where this came from. Now you're going to take that derivative with respect to y. Well, this time this one has no y, so it disappears. And you do this with respect to y, giving us the negative 18xy squared. Okay, your turn. I want you to do f of yx. So you should have started out with your f of y. And that was minus 9x squared y squared plus 14y. Now you're going to do that derivative with respect to x. Well, this one has no x, so it disappears. This one here, we're looking at the x, so that's negative 18 xy squared. I hope you did a good job. See, they're not too bad, right? Let's go down here. All right, I want to find f of xx and f of xy. So the first thing we do is we find f of x with respect to x. Well, this has an x. We know the derivative of e is itself, so this is just itself. This one with respect to x, 3 times 8 is a negative 24x squared y squared. We're going to use this one to find both of these. So now we're going to do this derivative with respect to x again. So again, this one stays the same. Here we make the 2 times a negative 24 and we get the 48xy squared. Now we're going to do it with respect to y. But this time when I do this guy with respect to y, the 2ex does not have a y, so it's a constant and it disappears. So now you take this 2 from the y and we get the negative 48x squared y. All right, your turn. But now I want you to do y. I want you to do y and yx. Same function. Okay, give it a shot. Okay, f of x, y with respect to y. So the first one has no y, so it's gone. The second one is negative 16x cubed y. Next, we're going to do f of y. Now there's a 1 here, so this is just a negative 16x cubed. All right, I hope you did a good job. Okay, now I want to do f of yx. Well, to do f of yx, we're starting off with f of y again, nothing different here. Then the f of yx of xy is equal to, so we're doing this guy again, but now with respect to x, well, this time we're going to take 3 times 16, which is a negative 48 x squared y. I hope you did well. Those are kind of fun. Just be careful what variable you're using. Now we can also do it with 3 terms. So we can do f of x, y, z. Again, I can do this with f of x with respect to itself, and then f of x, z, I do this one with respect to z. So we do the x, so that's these two we're looking at, 4x, yz squared. Next, we're looking at these two, so it becomes 3x. Here there is no x, so he works as a constant. Now we have to do this with z. This one has no z, so he's gone. Bring the 2 in front, and we are left with 8xyz. All right, your turn, but now you're doing it with respect to y, and then yx. So if we do with respect to y, so the first one will become 2x squared z squared, because the y is going to go away, plus 6xy minus 4z. This time we had all of them because they all had a y. So now we're looking at my function with respect to x. At least the one we just had. This one doesn't have an x, so he's going to disappear. This one we look at this part. We have 4x. Nothing else. Let's get rid of that. Maybe not. There we go. 4xz squared plus 6y. And that's finished. There's nothing else to do. All right, I hope you did a good job. Good luck on your homework. Take your time and post questions if you have any.